Hi, everybody. Let's go ahead and finish out example one of this section. So here we have letter D, the integral from 1 to 2. And we have this strange looking function here, 2 over s minus 4 over s cubed. S is our variable and ds is our differential. So let's go ahead and integrate this. So what I need to do is rewrite this s cubed. I'm going to move it up to the top. And maybe take out this 2 so that it'll be easier to see what the integration of 2 over s would become. But let's rewrite it. We have integral from 1 to 2. I'm going to take out the 2, so it'll be 2 times 1 over s. And I'm going to bring up that s cubed. So I'm bringing up that s cubed to the numerator, making it a negative exponent so that I can integrate. Okay, don't forget your differential. So now I can integrate this function. Notice that 1 over any variable is just going to be natural log of that variable. So we have 1 over things like 1 over x without the natural log of x. So we have s as our variable, but it'll be the same thing. So this becomes 2 times natural log of s minus 4s to the negative 2 over negative 2. And we're integrating from 1 to 2. Okay, so this cancels out. And what we are left with coming back up here is 2 natural log of s. The negative 4 and negative 2 make it a positive. So plus 2s to negative 2. And we're evaluating from 1 to 2. And so to clean this up a little bit, for when we plug in 2 and 1, we can have 2 natural log of s plus 2 over s squared, evaluating from 1 to 2. So we integrated, and now we're good to go to plug in 1 and 2. So what I'll have here is brackets 2 natural log of 2 plus 2 over 2 squared minus 2 natural log of 1 plus 2 over 1 squared. Okay, so since we're dealing with natural logs, I'll go through some of the steps a bit. So I'm going to leave the natural log of 2 alone. I don't want to calculate it. I don't want to calculate natural log of 2 just because it'll be some long decimal number. So I'm going to keep it exact. So what this first bracket becomes is 2 natural log. We know 2 is positive, so we can drop off the absolute value. And then 2 divided by 2 squared is 2 over 4, which is just 1/4. I'm sorry, 1/2. Minus 2, natural log of 1. Well, natural log of 1, if you put that in your calculator, you're going to end up with 0, because the natural log of 1 is always going to be 0. So this will be 2 times 0, which is a 0, plus 2 divided by 1 squared, which is just 2. Okay, so this is our solutions looking pretty good. What we end up with is 2 natural log of 2 plus 1/2 minus 2. Because it's negative, distributes in there. Because you would just have 0 plus 2, which is 2, and then negative 2. So we'll just keep simplifying. What we end up with is 2 natural log of 2. And then 1/2 minus 2 is going to be You could have negative 1.5 if you want, or negative, but that's okay. And you could compute the approximate answer, but for natural logs, I like to keep them whole just so we don't have some uh long decimal to work with. But that's how you would do this problem here for letter D. Okay, so letter E now. This one's a little easier. Let me go ahead and close this off. Let me try again. Okay, so letter E, this one's a little easier. So we don't have to simplify or rearrange anything. It's going to be pretty straightforward. So the integral of this is going to be x cubed over 3 minus 2x squared over 2 plus 3x going from 0 to 1. So this is something you can simplify here, the negative 2's, but, so if you want to. This would be minus x squared plus 3x going from 0 to 1. And so we're going to plug in our limits. What we end up with is 1 cubed over 3 minus 1 squared plus 3 times 1 minus 0 cubed over 3 minus 0 squared plus 3 times 0. And so here, if you guys notice that it's just 0 divided by 0, I'm sorry, just 0 and 0 and 0. So we're not going to worry about that bracket because it's all going to go to 0. So what we end up with is this first bracket here. I'm going to calculate it. It'll be about, well, this will be 1/3 minus 1 plus 3 minus 0. So then 1/3 minus 3 plus, sorry, 1/3 minus 1 plus 3 is going to be 7/3. And that would be the answer. So when if you've noticed so far that if we have a 0 as a lower limit, it's almost always going to go to 0. So if you can identify that right away, you don't even have to worry about this part. You can just focus on this part and not even really write this, to be honest. You can just write minus 0 like we did here. But, if it helps you to write it out, go for it. But if you feel like you get the point, then also go for it as well, if you know it's going to be 0 anyways. So that's a little helpful hints for that. But let's go ahead and finish off with these last two examples for example 1. So for letter F, we have 1/2 times the integral of 0 to natural log of 2 e to the x dx. So don't be too scared by this, because remember that this natural log of 2, we even had the example above. This is just a number, right? It's going to be some type of number that you're going to get. It's just not an exact number. And we have a different situation here with the 1/2 out in front, but it's a coefficient. It's one of those integral properties, and we can just worry about it later. So this is just an easy integral because the integration or the antiderivative of e to the x is just going to be itself. So what this ends up being is just 1/2. The 1/2 comes along with us for the ride, and it's just going to be itself, e to the x. I'm integrating from 0 to natural log of 2. Okay, so now I can evaluate at my endpoints. So it's based on your preference. You could do it with the 1/2 or you can leave it outside. I'm going to leave it outside and just deal with, or you know what, I'll do it attached. So it's going to be 1/2, and put my brackets, e to the natural log of 2 minus 1/2 e to the 0. And so e to the natural log of anything, well, that e and the natural log cancel out if you can recall your exponent properties. And then e to the 0 is always going to equal 1. So what this simplifies out to is 1/2 times 2 minus 1/2 times 1. And so we are left with 1 minus 1/2, which is just 1/2. So maybe I jumped a little bit, but you can remember that e raised to a natural log of x will always just equal x. So in this case, the e a natural log of 2 will just equal 2. Okay, so that's letter F. Let's go ahead and finish out with this last example here. For example 1, letter G. We are integrating from 0 to 4 of the function square root of x dx. So remember that we need to rewrite this a bit. We can't just integrate right away. We need to rewrite this square root of x. And how we would write the square root of x, we can rewrite it as x to the 1/2 power. So if I rewrite this, this would be integral from 0 to 4, x to the 1/2 dx. Okay, so now I can integrate. So this would become x to the 1/2 plus 1 is 3/2 over 3/2, and we're integrating from 0 to 4. Okay, so that 3/2 flips, it reciprocates to become 2/3. So this becomes 2/3 x to the 3/2 going from 0 to 4. So let's go ahead and plug in our endpoints. So this becomes 2/3 4 to the 3/2 minus, and like I said before, if you have a lower limit of 0, you know it's going to be 0 because if you plug 0 into this, it's going to be 0. So I really don't have to write anything. I can just write minus 0. You don't have to write 0 if you want, but just it's going to be 0, so you can kind of jump straight there. And so I'll leave you to the calculations there, but what you should end up with is 16 over 3, which is the same thing as 5.33 if you use your calculator. But that should be the answer for letter G. So that's a couple more examples of definite integrals, just a couple different looks at it with different functions. But thanks for watching, and I'll see you next time. Thank you. Bye.